This is the third installment of my review of the AI conference, which, by the way, is not finished. I'm going to attend one more session tomorrow, which is actually architecture for autonomous vehicles. And that's the reason of this episode, actually. That's a good segue. I want to summarize this event and prepare myself for the Tesla AI Day. This is the ultimate purpose of this whole exercise, of course, is to understand where the industry is going and calibrate that against our portfolio, which, of course, Tesla is the largest position. So we need to understand where is the industry going in terms of hardware and software, and then where's Tesla stand relative to that. I think this is the key. And one of the insights we already got, which is wasn't AI driven, but we heard from OEMs that the Tesla OS, the car OS, is a huge competitive advantage, and therefore already one big item that we want to keep in mind when we deal with Tesla as an investment. Now, when it comes to AI hardware, and particularly, again, this conference was about hardware, so it wasn't software driven, but like everything, and this is one of the big themes, that we have this merge between software and hardware. We're going across the stack. This is Onur Mutlu 101, that we have to look at the whole stack. We have to start with the workloads, the programming paradigms, and then go all the way down, maybe not all the way down to the logic layer, but definitely we have to talk about ISA, instruction set architecture. We have to talk about, even the kind of the devices under the ISA, the logic, and think about how we want to design systems. And this particular episode should be hopefully a good summary and also a prelude to what's coming with Tesla ID and questions for Tesla. This is Not Even Wrong podcast. It's September 14, 2022. Again, this is the third installment of today. So there hasn't been any new updates. For the year, we're down 24.7. The market's down 17.5. We're underperforming by 7.2%. So let's jump right into it. So we have a couple of takeaways from the conference, and one is the merge of edge and the cloud. So we have the idea that we have edge computing and cloud computing is born out of necessity. Like everything almost in life, we have nomenclature for things that are sort of coming our way. In other words, we had, for example, in the past, we used to have long distance calls and short distance calls or local calls. We don't have that anymore because the technological and economic realities are such that it really makes no difference. We used to have dial-up and non-dial-up internet connections. We don't have that anymore. Everything is wireless. So technology advances and makes a lot of things obsolete. So in that sense, also, we believe that edge computing and data center computing at some point will merge into one thing, which is computing. And the compute will be done at the most relevant level, wherever that may be. We've spoken with industry specialists. I don't need to mention names now. It's not that relevant. For example, you have this idea that you have edge computing. Take, for example, a drone. A drone flies and needs not to crash and needs not to fly into something else. For that, you need AI. You need something like, let's say, you need image recognition and then control or something that guides the drone. All of these things can be done at certain levels in the data center, at certain levels closer to the drone. There are 7 different layers. I don't remember exactly the details, which ones, but one of them is, again, the data center. Then one of them could be more, let's say, in the metro area, if we're in the city. Then one could be closer to the cell tower, and then we can go all the way to the drone itself. Now, the constraints that we have is, at this point, I would say primarily power. So the reason you can't have a large learning algorithm running on the edge is because it would consume too much power. So this is the constraint, and our conjecture is that at some point we will have solved that constraint. And there's a lot of work going into that particular problem. And now we translate that to Tesla. I guess the question to Tesla, the first question would be, how do you feel about the merge between edge computing and data center computing? Is that something that you're starting to architect as one big compute problem, or is it still separate? Where do you stand, let's say, in terms of learning on the edge? Is that something you could do? For example, neuromorphic computing, one of the companies that we spoke with, Neuromorphics, claims that they can do learning on the edge. Where do you stand when it comes to that? We have a panel tomorrow where Rivian is going to talk about machine learning on the edge. Now, machine learning on the edge could be just inference, which is something Tesla is already doing. The question is, are you doing learning on the edge? And what are the pros and cons of doing that? For example, one of the pros of doing learning on the edge would be that you can faster react to the environment. The cons is, again, its power, its cost. So that's one of the big themes that we would like to discuss on the Tesla AI Day. The second theme we want to discuss is the concept of the idea that we could have all new computer architecture. Now, this is a big idea. In my last episode, I threw out the question, which is, if John von Neumann was sitting on a panel today, he would look at us and say, why are you still using my architecture? Obviously, you have a different use case for computers than what we envisioned back in the 1940s or 30s. We thought that it's going to be the John von Neumann architecture, which is a program that gets programmed and executes. But what you guys are doing is you're building algorithms that are fed data, and then those algorithms turn into executable, turn into something that executes. And that's obviously very different because it's incredibly data-driven. The work that's being done on the data side of things is there is the protocol CXL. I want to look into that. So this is a CPU to memory interconnect. There is work being done on general, the Honor Mutlu ideas that you have more logic in the memory side. But in general, again, we have this new paradigm of data programming algorithms to do execute tasks. And therefore, we need to find more data flow models, for example. In general, I asked the question, if John von Neumann was still alive, what would he say we're doing here? And he would probably say, why the hell are you still using my paradigm? Change the architecture, make it more of a data-centric architecture. And I think the way ML and AI and all these things are standing today, it is absolutely paramount that we find more data-centric architectures. Now, there has been also, let's say, the idea of software-defined hardware is very interesting. And I think that's something I want to talk to Tesla about on the AI Day, which is how can we merge the edge with the data center? How can we make this one big compute problem and then use software to decide which workload is done where? I think the second question I want to ask is, what are your thoughts on neuromorphic computing? Can we have learning at the edge? What are your thoughts on that? Where do you stand? Because learning and inference at the same point can be very beneficial. Think about it. You have a machine which, while it's driving, learns. And I think somebody like Elon Musk should understand that really well, because if you send a machine up to Mars, you can't send data down to the data center to learn. So this is very, very interesting. And I think I discussed the neuromorphic compute more in the previous episodes. Here, I just want to say that the idea is that we have something more brain-like in a sense that it uses a lot less power to get the job done. So this would be the second question. I think the third question I have for Tesla is, when it comes to, and this is the big question, when it comes to the actual approach of AI in terms of self-driving, can we use self-supervised reinforcement learning? Is that a possibility? Where do we stand? Because the mu-zero approach, the DeepMind approach in general, but the mu-zero in specifically is so much more promising. Where do we stand? Can we expect that to be used? And if so, if not, then why not? Those are the big questions I have. So infrastructure question, hardware question, software-defined hardware questions, and then, of course, the big question, the self-supervised learning question. Thank you.